Hey ladies and gentlemen, welcome back. This is 9.2. I'm probably going to break this video into two sections because it does get pretty involved. I will put up the majority of the work. You'll see as we go through here, you're finally getting into what you would call three-dimensional analysis, and you can actually start applying a lot of this math to what you would think are complicated structures or architecture in the world, and you kind of get an idea of what you're looking at and how they came up with it. So identify the horizontal asymptotes of the following functions. This shouldn't be too bad. You've had a lot of practice. Remember, horizontal asymptotes are whatever we're adding or subtracting on the end. This would be growth. You're starting at a half. And so your horizontal asymptote here will be 0. In B, horizontal asymptote would be plus 8, so we're looking at positive 8. In number 2, identify what values are not in the domain of the following functions. So what values won't work? In A, the only value that won't work here is if you were to divide by 0. So the only value that won't work is when x is 0. In B, we want to know when x squared minus 9 equals 0, because there are no square roots. So what we're going to do is factor this. This is x plus 3 times x minus 3 equals 0. So you can see x is negative 3 and x is positive 3. Those are the two values that you cannot put into that function g of x because they were going to give you an error. In h of x, set 3x squared, it looks like, plus 7x minus 6 equal to 0. So I'm going to do 3 times 6, which is 18. Numbers that multiply to the 18 are the following. So what I'm going to do here is I'm going to write 3x squared plus minus 6. The two numbers that have a difference of 7 are 2 and 9. So 9x needs to go with the plus, 2x has to go with the minus. You can see that these two here where my pen is will make 7x when you combine them. GC after the first two is 3x. This is x plus 3. GC after these two is negative 2, leaves me with an x plus 3. So x plus 3 gets pulled out, set equal to 0. X cannot be negative 3, that's a no-no, that will give us 0. The other one that's left is the 3x minus 2. So 3x equals 2, x is equal to 2/3. So the two values here that you can't have are negative 3 and 2/3. They are not in the domain because they will give you errors when you plug them into this guy. So that's 1 and 2. We're going to talk about what's right below it. Okay, so if we take a look at vertical asymptotes, these are a little more involved. Okay, a vertical line that a function approaches but never touches. Exactly like the horizontal asymptote, but it's a vertical one. Vertical asymptotes exist at the x values that are not in the domain of the function. What you just calculated basically in number 2, that would be a vertical asymptote. The hyperbola is a conic section curved in the form of y equals ax plus b over cx plus d plus e. You're going to get tired of seeing this guy here, okay? But you will see that a lot in this section. That is formed by the intersection of a plane and a cone. Hyperbolas are visible as the appearance of a circle from within, a path followed by the shadow of the tip of a sundial, cones of light. Here is a cone of light, right here. You can see them. Bunch of examples down here at the bottom. These are hyperbolas that are three-dimensional, hyperboloids. Many tall structures such as towers are designed with hyperboloid bases due to the geometrical structural strength needed to support an object high off the ground, and it's aesthetically pleasing in appearance. So you can see here, this is the Seattle Needle Tower, okay? That's in Seattle here. That's a hyperboloid. Most power plants are hyperboloids as well, so as you go out travel towards, I guess, what is that, Pottstown, you can see, power plants that are built with hyperboloids. All right, horizontal asymptotes. A horizontal asymptote, when you're dealing with a hyperboloid, is of this function, a over x plus e. That's your horizontal asymptote for a hyperbola. So that's new. Okay, with growth and decay, it was just the number on the end. Here now, you need to take into account the values that are in front of the x's on top and bottom. Now, so what we're going to do here is we're going to go down through this chart. I'm going to do probably the first 3 or 4, then I'm going to let you fill in the rest on your own. Okay, so I need to make my screen a little bit smaller so this whole thing fits here, doesn't it? Okay, so here we go. In number 1, I see that this is cut off. This is to infinity. Right, I guess I have to put it in a lighter color because it's off the charts. Right, so let's start with number 2 here. We're going to write it in the form as above. So I have 0x plus 3 over 1x plus a negative 1 plus 2. So A is 0, B is 3, C is 1, D is negative 1. E is positive 2. So the vertical asymptote, remember, is what the bottom, the domain cannot be. So I can't have positive 1 down here. So x is 1, because it'll give me an error. My horizontal asymptote, remember, is A over E, I'm sorry, not A over E, A over C plus E. So this looks like 0 over 1 plus 2. So that's going to be 2. Horizontal asymptote at y equals 2. Okay, domain. Domain will be all real numbers except for this guy. So I'm going to go negative infinity to 1, and then from 1 to positive infinity. My range, okay, will be from negative infinity to 2, and then I pick up a 2 and go to positive infinity. All right, so there's number 2. I'm going to change colors here. What should we do? We'll do blue here. All right, coming down to number 3, I'm going to have 1x minus 2 over 3x plus 3 plus 0. There's my equation in that form. So that means A is 1, B is negative 2, C is 3, D is 3, E is 0. Vertical asymptote. Remember, this is where your domain will be non-working. So 3x plus 3 equal to 0. So this is what I'll be solving. 3x plus 3 equals 0. So that's negative 3x is negative 1. Okay? Horizontal asymptote will be 1 over 3 plus 0. So that means y equals 1/3. Excuse me. So our domain is our x value that is not going to work here. So it'll be negative infinity to negative 1, negative 1 to infinity. My range is from negative infinity to 1/3, and that picks up at 1/3 up to infinity. Okay? And I'll do one more with you here in 4. Maybe I'll do 5, but the rest will be on you. Okay, and I'll check them if you want as I walk around. So again, let's get it in the form of 0x plus negative 1 over 1x minus 4, or plus negative 4, however you want to think of that, plus 3. The A value is 0, the B value is negative 1, the C value is 1, and the D value is negative 4. E value is 3. Vertical asymptote, this will be x equals 4, because that's the number that will give me 0 down here. My horizontal asymptote will be 0 over 1 plus 3, so this is going to be y equals 3. Remember, it is A, this guy is A over C plus E. Domain then would be from negative infinity to 4, from 4 to infinity. And then this will be negative infinity to 3, picking up at 3 to infinity. All right, and one last one for good luck, good measure here. I'll do it in orange. So this one here, y equals 0x plus 6 over 1x plus 3 plus 0. A is 0, B is 6, C is 1, D is 3, E is 0. Domain would be x equals negative 3, that won't work. The horizontal asymptote will be 0 over 1 plus 0. So this is y equals 0. So this is going to be negative infinity to negative 3, up from negative 3 to infinity. The range will be everything except for when you get 0 for y. So 0 to infinity. Okay? The rest of the chart, I'm going to have you guys finish up. Next time you see me, I'm going to be on the next page here. So, good luck, and I'm going to continue over to the next page. So, hopefully you can keep this data, because you're going to definitely use it later. So you can see we're going to get into graphing these hyperbolas. Okay? And if you're graphing the hyperbolas, the vertical asymptote and horizontal asymptote definitely make your life easier. Okay, so what we're going to do here is I'm going to go down here to 2. We're going to use some of these points here to help. Okay? So when I look at this, my horizontal asymptote here is basically going to be, remember, this is 0x, so 0 over 1 plus 2. That's y equals 2. As far as my vertical asymptote, that's going to be x is equal to 1, because that will give me 0 in the bottom. So what that looks like when I start graphing this is x is 1 here, so I know I won't touch this line. And horizontally, I know I will not touch y equals 2. Okay? So what I'm going to do is I'm going to start testing points that are around this x here. So you can see, okay, if I go to plot, I don't know, let's put 0 in for x. If I put 0 in, I get 3 over negative 1, so that's negative 3 plus 2, that's negative 1. So 0, I'm at negative 1. We're going to put negative 1 in. So that's 3 over negative 2. So that would basically be negative 1 point, as I start writing that in a fraction, negative 1.5 plus 2. So we're looking at a negative half. And you have a graphing calculator or positive half. You have a graphing calculator there, so don't be afraid to use the table. Just punch it in. And so I'm here. And I'm probably going to try negative 2 yet. So that would be 3 over negative 3, which is negative 1 plus 2. So I'm looking at positive 1. So I can pretty much see what's going to happen here. It's going to approach this asymptote and then take off down there. Okay? Now I know it's going to mirror up here, but it helps if I have some points to work with. So I'm going to put positive 2 in. Okay? So if I put 2 here, I get 2 minus 1 is 1. So this is 3 plus 2. This is 5. So 2 up 5, 2, 4, 5. Put 3 in. Okay, so I have 1.5 plus 2. That's 3.5. And I'm here. 1, 2, 3.5. And then I'm going to put 4 in. So that would be 3 over 3, so that would be 1 plus 2 is 3. So 4, 3. Again, you can see I'm coming from up top and then leveling out. That would be your graph for number 2. Right? Probably be able to sneak in one more problem here, but I think what I'm going to actually do is I'm going to stop here with this video. The next video, you're going to see me graph 3, 4, 5, and 6 and finish up on the back page. So I'll catch you guys here in a second. Hope you're good to this point. I'll see you on the next video.